Yes.
You didn't do one last time, did you?
I did not.
So you're up.
Okay.
Now, here's the thing.
Yes.
I need the model, but I also need for you to tell me which variables are collinear.
Okay.
And how are you going to get people to listen to you? Because so far I haven't been very successful. Oh, okay.
Oh no, I didn't put my collinears on. I don't do it. Okay. Let me grab my pencil. I will need it.
Okay.
Hi. I'm up here now.
Oh, you did get their attention.
I did. I told you I would.
Okay, over to the,
Whoa.
we're getting very close.
We are way over on the edge of the table. Okay,
What about
so
just?
Oh, I'll turn off the light. I'm sorry. See, you need to tell me that before I sit down. Okay, so you're going to give the model, but you're also going to talk about which variables are collinear.
okay, the model that I used is the multiple regression model, and my code. Can I show the whole thing?
Sure.
Okay. Let's see, the collinear.
Oh, we're going to need to move the paper up just a little bit. There you go, there you go, there you go.
There we go, okay. The collinear variables that I came up with were the sex and the HRMA, or if you're sitting at the Panera, it's not sex,
It's gender.
it's gender.
Oh.
Everybody kept staring at us.
Everybody was staring at us when we kept saying sex.
Oh. Sex, and which one is collinear?
The HRMA.
No, that's .0035.
Oh,
So-
hold on.
Okay, so sex
Sex
and,
and, I was thinking it was sex and weight, yeah.
it is sex and,
Okay.
so we cannot have sex and weight both in our final model.
Right.
Okay. Okay, now, can you give me the final model?
Oh, see, I'm just all final, okay, hang on, I'm just really brain cramped right now.
How do you determine that sex and weight cannot be in the
That's
final
my
model?
question.
Oh,
Oh,
One of them.
whenever you're going through, I can't remember the name of that chart. Oh, I'm gonna just be great on this one. Whenever you're going through that one model with the ones and the twos and the threes, if the, okay,
the final model
This one
cannot
here.
contain two
two of the
collinear,
same, yeah,
two collinear variables.
right. I knew what I was doing when I was thinking it, I just didn't know how to explain it. And you need the final model?
I need the final model,
Okay, which is going to be this one.
which is going, I'm not seeing it.
Oh, where am I?
Right there, right there.
Okay,
Okay,
yes.
now, bring that down just a little bit so you're not showing the answer to the next person.
Oh, okay.
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 Oh, a little, a little. That's
Here,
it.
here, there you go,
I
there you
really
go.
can't see what I'm doing, thank you.
Yeah, I know.
That's how you know.
Okay, so, I have a multiple regression model
So I
and
start
the
with one,
estimated
and it has the highest
SB
star splitters, so gender is the one.
PMA,
Mm-hmm.
which is the Y variable, equals the 98.07 plus 12.829. And then sex is the X variable plus, oh, I can't read my own handwriting, 0.2906 times HRMA.
Okay, now, the decimal places. We're going to, in our final model, we look to see what the maximum number of decimal places is, and they all have to be consistent then.
Okay.
Okay, so my raw data had 2 decimals, so my model's gonna have 3.
Okay.
So change 9807 to, 98.070. Let's go ahead and a 0.
Okay.
Yeah, put a 0 in
So
there.
we can go ahead and put a 0 in
Well,
there?
as I started this sentence off, I didn't know it was gonna be a 0.
Okay.
So,
Well,
and
yeah,
then
I mean, it could have been a 1, 2, 3, or 4,
Exactly.
as far as I know. Okay.
Yes. So then 12.829 is fine, and then .291.
Right.
Yeah, we have to be consistent.
Gotcha.
Can I ask a-
Otherwise,
I-
if
yeah.
one of those had, see, you had 4 decimal places for HRMA, so that implied that the other 2 variables, that everything were zeros, and that's not the case.
Okay.
Okay? Does that make sense?
Yes.
Okay.
To clarify on that one,
Uh-huh.
so our decimal places have to be one more than our Y value.
No, one more than our raw data.
One more than the raw data, okay.
So the blood pressures had 2 decimal places,
Right.
I believe.
And sex only had 0 decimal
Right,
places.
right, because
Yeah.
there's just 0, 1.
Right.
Yeah.
Can I ask a
Okay,
question
then
about the first chart?
I can't see
So,
where we're going.
yeah, you're good, perfect. So for sex and meds, which end do you want? The 0 or the 1? Does that make sense?
Right, we need to, if we were listing this out, she has her pencil in her hand, we'd say sex equals male. And
Oh, okay.
sex equals male, so usually you do the 1,
Okay.
and then meds equals yes. And I'm assuming that's the right values. 86 and 35, yes, yes.
So if I did sex equals female and meds equals no, would that be okay too?
It would be
As long
okay.
as I said what it was?
Right,
Okay,
right,
cool.
that would be fine.
Okay, so it doesn't matter as long as you say which one it is, okay.
If
But
they-
I'm just gonna say, but by tradition, there is a reason why they use a 1.
Gotcha.
So that usually that's the one that's of interest to you.
I would put female under 1, but that's just me.
Mhm,
That's just
mhm.
me.
And if we use both of them, is that not
That
good?
is fine,
That's fine,
that is
okay.
fine. Usually students don't like to write, and so it's like some sort of a, you mean I have to write both? So we've sort of said over time, well, if this is a dichotomous variable, the researcher can get the other by subtraction.
Okay, and I still have one, maybe I didn't understand the multiple regret. I'm really confused with why, I mean, the 0, I understand why it's there, but I don't I mean, is it just gonna be a 0 because we don't know if it's a 0, 1, 2, 3,
No,
or
we do
4?
know it's a 0, it's 98.07032, so the
Okay.
first 3 decimals,
Gotcha, okay.
.070.
Okay.
Now, can we go over that part again, because I don't know, oh, okay, cool. Awesome.
Well, that wasn't even a question.
I answered him.
Oh, okay.
She's just that good.
Very good. Oh, now you have to ask if there are any other questions.
Are there any other questions?
Okay, thank you. Okay, my next person is Terrell Wilson. Okay, now, Terrell, as you come up, I need the fit of the model, but I also need for you to show me what the value was for the correlation coefficient for sex and meds.
Okay.
For the fit of the model, the adjusted R squared is 0.2270. So 22.70% of the variability in the SBPMA is found in sex and HRMA.
We're going to replace the word found with explained by. Okay.
And then the correlation coefficient.
The correlation coefficient for sex and meds, if you would show us that.
Okay, since sex and meds were the dichotomous variables.
Very
I
good.
Did
Yeah.
a proc free. Is that on?
Yeah, it's a little blurry. Can you reach up on the lamp thing and at this end there's an orange button. Push the orange button.
Whoa.
Very nice. Thank you.
Nice.
A gift. Yes.
I can see it.
Good touch. Okay. I'm sorry. Go ahead.
And then we would look at the chi-squared section, and it had a probability of 0.0025.
And where's my coefficient?
And the coefficient is should be this p value,
Very good.
which is negative 0.2272.
Yes. Now, if we, on the proc core, sex and meds, did we have, can you show me what, we would not report out that, but can we just show, for illustration purposes, can we show that these are different values? So sex and meds,
Sex and meds, and it was 0.0024
Four.
for the probability, which I think the other one was 0.25. 0.0025. And
I think so too,
It was.
negative 0.2272
was the same. Yep.
But that's not what we look
Okay, ask if there are any questions.
at. Are there any questions?
I have.
Okay.
All right. So the first one here, that p-value that you found, you looked at the chi-square. Now I was
Right.
under the impression that we had to look at the Fisher's exact test at the bottom of the two-sided.
Well,
Because it is
you're only
a.
going to look at the Fishers whenever it gives you a warning sign, or a warning sign, which I think usually takes place
It's
down
usually,
here.
Yeah.
well, it's
A little
usually right
between-
between the two
between
tables,
those.
right there, yeah, yeah.
There'll be a warning sign there?
Yeah, it'll
Okay.
say warning. You see that, then you'll use the Fishers.
Yeah, it's a 50% warning.
Or
I've
it could
seen
be
it.
a 33%, or
Yeah.
whatever. 25% actually, I don't think you can do 33 because there's only 4 cells.
Yeah.
It's kind of like
Okay,
an
now
asterisk.
this.
That's the old boilers, but see the warning?
Oh,
You
yeah.
had it. That's the warning they're
You
talking
put up
about.
this warning sign right here. And it, I think it has to do with expected counts, not being above 5.
The expected values, expected frequencies, we'll go with that.
Were there any more questions?
I just have one, Dr. Murray. I just want to clarify, when you ask for, to specify the fit of the model test, will we always provide the correlation coefficient and p-value for the two dichotomous values?
No, that was just an extra thrown in to see if I could trip him up, and he did very well.
Okay, okay.
The fit of the model is just the adjusted R-squared with interpretation.
Any, oh, yes.
Sort of for Dr. Murray, since it's, if.
I don't want to hog.
I know, but, well, maybe you can answer this for me. On a test, would you be going for the chi-squared, the .0024 or the .0025, or is there leeway there?
You would go with the 0.0024 because you're doing the chi-square.
So you're doing the chi, okay, gotcha,
Because of the two dichotomous
gotcha,
variables.
okay.
The moment you see two dichotomous variables, Pearson's is no longer valid.
It's the
For those,
2.5, right?
just for those two, though,
What was
right?
the, and,
Because the
yeah, the chi-square p-value is .0025.
Yeah, and the Pearson's was .0024,
So
So
so,
we want the 2.5.
right, yeah.
Okay. Can't mess with my little brain
Just
like
making
that.
sure.
Like that.
Making sure.
I just want you guys to notice that they're very close,
Yeah.
but they are not the same. Usually they are not the same. Okay. Okay, then we need the outliers. We were using the H statistic, although we certainly could use Cook's D or D fits, but this just specified the H. So, Mr. Yim?
Yes. First, I would like to tell you that my final final model is different than yours because instead of a sex, I input weight, so I might be wrong. And the result of my outlier for each statistics is my cut point is 0.0339, and the among 177 observations is 10 observations is more than the predicted value.
Well, the predicted means what model, what
No,
did the
that's
model?
my final model.
So for each of those observations, there would have been an actual Y value and a predicted Y value. That 0.0039 is, as you've indicated, a cut point. It's not the predicted.
Cut point.
Right, cut point.
Mhm.
Okay,
Yeah.
so let's edit these. Yeah, let's edit these observation numbers. Class, what did you get for your outliers? Number 40,
40, 67, 128, 156, and 176, yeah.
156
And 176, right.
and 7.
One, 120, yeah, 128, 156, and 176.
Sorry.
Oh, you're fine.
Yeah.
okay, any other, ask if there are any questions. Any questions? Yeah.
I have my kids. But,
Oh. You're not supposed to have a
Sorry.
question. You're presenting.
I have,
Is there any more questions?
I have a question, but it's up to her preference. Do you want us to actually list the actual numbers at this point, or do we just need to get the observations?
Well, I thought we all understood where those actual and predicted values were coming from. So it would be, I'll prompt you on a test. If I want the actual and predicted, I'll tell you. If I just want the observation number, I'll tell you.
Well, I just want to make sure, because I just gave the observation number, and if I get called up there, I want to make sure I have all the data for you, so I didn't know if I needed to list the actual.
I thought that it probably was no longer necessary to.
Yeah, this
Okay,
one
so I
only
can
asks
just
for
list the
observation.
Observation number, yeah.
Hey, look, I missed the days, like
But-
the whole world, man.
But everybody understands on that table where to find the actual and predicted, that same table. First and second column, I think.
Yeah,
Maybe.
Pretty much.
yeah.
The observation.
Well, the first column is the observation number, but then the second and third column are the actual and the predicted. Okay? Oh, yes, question. Sorry.
About the final model.
Final model?
Because I
Uh-huh.
I'm over here.
Okay, who is my final model person? Can
sorry.
you show us your adjusted R squared table?
Okay, hang on.
From the SAS output?
Yes. From the, no, not from, I didn't print out the SAS output.
You didn't print out the
no.
SAS output? Actually,
Yeah.
I have it.
My
Yeah,
work
but you
decided
have
to
it
cut me
in
off.
Could you do like 2 pages to a page?
Which we're supposed to be doing.
I did it at home.
Okay, unless you print it out. Oh, actually, I'll take it. I want the adjusted R squared.
I didn't know it was that long.
And there was a lot.
Huh?
It was a lot.
Now, this only has 3 variables, and I think in our reduced model we had 4.
We had
Three.
Of course, we just had 3. We just had 3. Just measure. Okay, we just had 3. It wasn't as complicated as it thought. Okay, so here we are. So we have sex, weight, and heart rate. So we find the best one. Can I mark on the paper?
Go right ahead.
Okay. We find the best one, and we note that the adjusted R squared is 0.15. Okay? Now we go to the best 2, which is sex and HERMA. Sex and HERMA are not collinear, it was sex and weight that were. So, sex and weight can both be in the same final model, and we look, not only do we check collinearity as we go from 1 to 2 variables, but we check to see that the adjusted R squared has increased by more than 0.05, or greater than or equal to 0.05, which it has something, 0.07. So, we look at the 2 variable model, then we look at the 3 variable model, and we've got 2 problems. Not only does the adjusted R squared not increase by more than 0.05, but sex and weight are both in this model. And we can't have sex and weight in the same model. So we went with the best 2.
Where I made mistake is the original model, because I saw the my wrongdoing is that I saw the correlation coefficient and the sex and weight something should be eliminated.
Right.
So I eliminated one thing. I mean, my case sex. I eliminated sex and put
Oh, it is not an arbitrary decision.
That's
We all will be following the very same rules.
Yeah, and then the only we can see the final model. Just make sure sex and weight
Are
cannot be
not-
there at the
So
same time.
don't eliminate any variables until you see these adjusted R squares. Okay?
Yeah. And what about the coefficient? Sorry, Pearson's correlation coefficient is that we can compare dichotomous one and continuous one.
If there's one dichotomous and one continuous, we can use a Pearson's correlation coefficient.
And
It
what
is
about
only with 2 dichotomous that we can't use
so
Pearson's.
among 2 dichotomous variables we cannot use Pearson's?
Right.
Thank you.
It's an invalid test for 2 dichotomous. And on your write-up, you're going to say Pearson or Phi correlation coefficients.
I just put phi in parentheses.
No,
Is that not good?
close in
Okay.
parentheses is the p-value.
Okay.
Otherwise, the researcher's going to see the thing in parentheses and think those are p's. They're not. They're p's. We have so many words rhyming here.
I have a question.
Uh-huh.
What's the shape of that residual?
I said random.
What?
What?
I said circle.
I initially said circle, but then I saw that outlier that was up in the corner, and I said,
That made it random.
I still said circle, but then I got with some of my people, and they said, yeah, we think it's random. Yeah,
Your people need to talk to his people. You have to.
I thought it was a circle.
I thought it was too at first.
It says circle right here. I don't know what you're talking about.
Yeah, well, on the the thing, there was an outlier like way out here, so that's the only reason why I agreed with my
You have
people.
to regret the day that I ever said circle instead of random.
I said bunny.
Yeah, mine look like a circle.
Can you bring that down just a
Yes. Thank you.
So it's a little flat on this end. Let's see, teardrop,
I went thumbs up actually.
I said bunny. I think somebody said armadillo. I don't know.
You only gave us way like
Hardest part of the
okay, so,
trying to figure
we
that
know
out.
it's not a wedge.
Right.
Mhm.
I think you need to keep it down to A and B, wedge or random.
Wedge or random, probably that would be wise, and the next time I teach this class, you can know.
You did it last time.
It's so controversial.
Can I ask a
Yes.
code question?
I said circle and the entire class turned on me. I was lucky to escape with my life.
You're like the boss of 9 to 5, right?
Okay, everybody got their homework? Yes? Okay, since there was a little bit of confusion last time, I'd sort of like to outline our steps again. Because when is our class in a week?
From Tuesday.
A week from Tuesday? Okay, a week from Tuesday. And, let's think in terms of, well, I'm gonna be writing. We can turn the lights on if you can't see them. It's too dark. Okay, so basically, I'm gonna turn my paper model. And I'm gonna do 3 columns here. So the first column I'm thinking of is for manual calculations. And I can make that. Okay? Now, manual calculations are appropriate only for linear. So let's outline the steps. Step number 1, we're going to do a Pearson's correlation coefficient. CC stands for correlation coefficient, R. So we calculate R. There are how many formulas are in the R formula?
3, 4.
4, I think. We have sums of squares of x, y, xy, and then the formula for R itself. So there are 4 formulas. Then, after you have computed R, this is sort of like a part A, part B type situation. Then we're going to do a hypothesis test, H sub naught. We're going to do H sub naught, H sub A. We're going to do the 6 steps for a hypothesis test, where we test to see if the population correlation coefficient, rho, is equal to 0. So this is 6 steps. You have a formula for degrees of freedom, which is what? N minus 2, very good. You have a formula for the test statistic. So there's actually 2 formulas within your 6 steps of your hypothesis test. Okay? Then we're going to do, second step is to determine the equation for the line of best fit. And this is by what method?
Least squares.
Thank you.
Thank you.
Yeah, let me know, because I lose track. I don't pay attention. What is this? We're finding the equation for the best fitting line by the method of
Least squares.
least squares. Very good, very good. Now, the b sub 1, the slope, and the y-intercept, those each have a formula. And then you have to write, so there's this formula, then b sub naught, b sub 1, so there's 3 formulas. And remember, you have to write the equation then in terms of words. Estimated, whatever, is equal to, you can't use x and y in here when you specify the equation. Okay? Then, this b sub 1 is of interest to us, the slope. We're going to find a confidence interval for b sub 1, the population slope. So this is beta sub 1. So that's one formula. Okay, and this has an interpretation. I am 95% confident that the population slope is within the sample. And then I can also do a hypothesis test, so 6 steps for determining if beta sub 1 is equal to 0. So once again, 6 easy steps and 2 formulas. Oh, no. How many formulas within this? Well, actually, the confidence interval. The confidence interval is in terms of the mean square error, yes? Okay, so how do I get to the mean square error? I start out with the total,
Model.
then the model, then the error is by subtraction, and then I divide by the degrees of freedom. So there are actually, let's do it this way. Both of these use the, I'm going to drop down here. Both of these use the mean square error. which is 4 formulas. Your 3 by 5 card is going to be very full. Okay? Is there anything else? Manually, I'm not interested in you doing a scatter plot. Mostly because I don't want to break it. Is there anything else that we did manually for linear regression? No? Can't think of anything. Okay, now, in SAS. I'm still working with linear regression. I'll just put RE2. Okay, so working with linear regression. Okay, now when I use SAS and I'm reporting out the results to the researcher, what do I start with? The what?
Title.
Title, which contains the
Who and the what.
the who and the what? Okay, that's pretty easy to do on a linear regression. Multiple regression, there's too many whats. So usually we just, well, we'll talk about that in just a moment. Okay, then what comes next? Summary statistics? Summary stats? Okay, now for a quantitative variable, what am I going to report out?
And mean, standard deviation,
Very good. I'm going to do SD for standard deviation. Very good. And these are going to have what? One more decimal than the... For a dichotomous variable, what am I going to report out?
number in proportions.
I'm going to go with percent, but the n and the percent per, well, let's do this. Usually, it's for one of the categories. I was going to say per one category, but for one of the, and usually it's for the one. But I can't say, like, I can't say sex equals 1, because does the researcher know which sex that is? No. So I have to go ahead and say, so I'm going to put the 1 here in quotes. I can't use a 1 in my report for the researcher. Okay? What comes next? We have summarized one variable. Well, we've summarized each variable by itself, so one variable at a time. Now we go to what?
Correlation.
Correlation, which is 2 variables at a time. Okay, so we're going to do what?
Correlation.
Pearson. And if we have a dichotomous variable
B.
for phi, correlation coefficients, and then usually I indicate p-values in parentheses.
For linear regression?
Pardon?
Like, do we do phi for linear regression? Only 2 variables and 1 variable have to be,
Curiously enough, you can do a linear regression where one variable is dichotomous.
Okay.
It's not ideal, but you can. So, but you're absolutely right, we don't have a phi because we don't have 2 dichotomous. So I'm quickly erasing this. But hold that thought until we do the next column. So this is a Pearson correlation coefficient. Is that Pearson correlation coefficients with p-values in parentheses. P-value in parentheses. And then we're going to write a conclusion. So we have one Pearson correlation coefficient, R, equals, and then based on that p-value, we're going to say that R is significantly different or not than 0, which implies that there is a significant correlation. Very good, very good. What comes next? The model? Y hat equals B sub naught plus B sub naught x. We probably should be numbering these. 1, 2. Okay, B sub 1 is gonna have a what? Confidence interval? Plus an interpretation? Okay, what else goes along with my model?
The fit of the model.
Fit of the model, very good. And the fit of the model is determined by what?
Adjusted R squared.
The adjusted R squared. And does the adjusted R squared have an interpretation?
Yes.
Start writing interpret. Okay, what else? Along with the model.
Outliers.
Yeah, I'm gonna go with assumptions first and then outliers, but, yeah. Assumptions. How many assumptions? 4. And 3 of those are for the what?
Error.
3 are for the error terms, of which you're going to define. How do we define an error or residual? Actual minus predicted? Okay. Then we're going to say outliers. How many methods do we have? 3. How many formulas do we have?
2.
Okay. So you would not be writing down the formula and the cut points for the researcher. He doesn't care about that. But I care about it on a test. Is that all? Okay, let's move to SAS, multiple regression. Can you see? Yes, you see? I can get linear and, okay. Do we have a title for multiple regression when we do it in SAS for the researcher?
Yes.
Okay, so we still have the who, the what now, because we have so many whats, usually we limit that to the y variable.
And how would we state a title? Like for example, the homework we just did. How would that title look?
Okay, so did we know anything about the who's? I can't remember.
The
It
clues
was
were
on page 76, the problem.
the male and female. We know they're around their
we
age.
don't have any, we don't know who these subjects were, so we would
Okay.
just say subject's blood pressure. Predicting subject's blood pressure. Oh,
Okay.
and which blood pressure?
Okay.
The
systolic
systolic blood pressure while doing mental arithmetic.
Okay.
Okay, so we didn't have a lot of description.
That makes sense.
Okay.
So